Let's welcome Charu.
So, can you hear me? Okay, perfect. So, I am a machine learning scientist at a company called Peak Power Energy, and I work on energy storage and I forecast energy demand for Ontario. And recently I've been getting this question a lot, which is, how do I get started in machine learning? I think there's a lot of hype and a lot of interest in machine learning, and I thought it might be useful for some of you that are thinking of getting involved in this field to hear. What happened? Maybe you can sort that out. So basically, today I'm going to be talking about how I went from having a very unusual and unorthodox background and how I got involved in machine learning. It's okay. So I think the reason I get asked this question a lot is, like I said, I have an unusual journey into this field. I started out in machine learning, in biology. I was a filmmaker for a bit. I founded an agricultural startup. And then I somehow ended up at U of T to study machine learning. And basically my takeaway is, if I can do it, I think you can do it if you're really interested and passionate. The caveat, of course, is that it requires a lot of hard work and discipline. But if you've got these two elements, I think you can totally become a machine learning practitioner. So I tend to break down how to get involved and how to get into machine learning into 5 broad categories. One is learning the actual coding, becoming a practitioner, learning the math, and then learning the actual theory, the ML content, learning how to read machine learning papers is really important, and then working on your own projects. So to start off with the coding, I was recently at a hackathon, a machine learning hackathon where I was mentoring, and I noticed that a lot of the participants were using different languages like R and MATLAB. But in my opinion, if there is one language you should dedicate yourself to, it should be Python. I love Python. It's super easy to learn. It's already ubiquitous. A lot of ML practitioners and researchers already use it. There's a lot of data libraries that are built around Python. And it's the first well-supported language for TensorFlow. And TensorFlow, if you've heard this name drop before, is an open source ML library that was created by Google. And amongst other things, it makes creating neural networks, for example, really easy. And it also supports GPUs, which when you're dealing with very large data sets is invaluable. My favorite resources, if you're thinking of learning Python and TensorFlow, MIT has a great MOOC online for their Intro to Python course. And then in addition to reading the TensorFlow documentation that's available on the internet, there's a machine learning engineer at Snapchat who has made a great library on GitHub available of TensorFlow examples and tutorials that I still refer to and I think are a really great resource to learn how to use TensorFlow and Python. Now in terms of the math, I'm assuming many of you are engineers and computer scientists, so I think you probably already got this down, but it's really important to know linear algebra because we tend to represent our data as matrices, for example. Also having calculus having a fundamental calculus understanding is very important. Eventually, if you really want to become excellent, you're going to have to understand statistics and probability theory, but I think to get started in ML, linear algebra and calculus are key. Now, in terms of the actual theory and learning the ML content, I tend to break this down into 4 categories. It's tapping into textbooks, online courses, video lectures, and blogs. So if there's 2 ML textbooks that you should own, in my opinion, they are Pattern Recognition by Chris Bishop. It's the textbook that you'll see in every introduction to machine learning course at every university. It's something that I still refer to from time to time. And then the textbook Deep Learning by Ian Goodfellow et al. Was recently published, and it follows more recent advancements. Now, these textbooks can be a little hard to get into, but if you are consistent and are patient with them, they're totally helpful resources. In terms of online courses, I think Stanford does a really good job at making its content available online for free. 2 courses that I've really enjoyed learning are their computer vision course and their natural language courses, which they're also both very interesting genres of machine learning as well. And the syllabi and the notes from these courses are available currently, but I think you have to dig around on YouTube to find the actual lectures. And speaking about video lectures, there are two Canadians, in fact, that have really great machine learning lectures available on YouTube. Nando de Freitas was a professor at UBC. He's now at Oxford and Google DeepMind. His lectures are available online. They're really excellent resource. And then Hugo La Rochelle, who's now at Google Brain in Montreal, has made these very thorough 10-minute segment lectures that that I found also very useful. But sometimes these courses and these online resources are quite intimidating, and I will often rely on blogs by machine learning practitioners and researchers that are really talented at simplifying complex topics. Two blogs that I keep referring to are by two Torontoians, in fact. Andre Karpathy and Christopher Olah have really great blogs that they update regularly, and they simplify very complex topics. And then if you want to go from good to great, eventually you'll have to start reading research. Reading scientific research is how you become more creative, in my opinion, how you have a nuanced understanding of the field. It can be difficult to get started reading research, but if you do it consistently, if you take your time, even if you have to read a paper a dozen times, it's totally worth it. And fortunately, in machine learning, a lot of these papers are published for free. They're not behind the paywall. If you're looking for a place to start or to find which papers you should be reading, Archive Sanity, which was created by Andre Karpathy, is a great index of some of the most popular papers that are coming out on a regular basis. And then Professor Sonia Fiedler, who's actually here at U of T, has a good reading list of computer vision papers on her website, on her course website, that will keep you up to date. And then finally, there's no use in just reading about machine learning. You really have to apply it. And how many of you have GitHub accounts, for example? Okay, good. I'm happy to hear that. So I think it's really important to set up a GitHub account. It's how I got my job, in fact. I was scoped out on LinkedIn, and my employers checked out my GitHub and realized, oh, I can actually code. So it's really important to have a GitHub that you maintain, that you code daily, and you make daily commits. And then also, it's important to use real-world data sets, because that's where you learn the nitty-gritty, the challenging part of dealing with data. Is that not everything is going to work out. Sometimes you have to clean data. Sometimes you have to deal with missing data, for example. So that is really important. And then also building things that interest you, that will cater to your interests. If you're looking for interesting data sets, if you're looking for inspiration, I think Kaggle is a really great resource, and you can get their data sets available for free as well. So if you are interested in getting involved in machine learning and you're thinking of developing a roadmap for your self-studying, for your learning, I think it's important first of all to just get the basics out of the way, to learn Python, for example, to learn linear algebra and calculus. And then making a schedule for yourself to do these online courses, watching these lectures, reading papers regularly. Doing those consistently will really make you a strong practitioner. And then also building projects on the side and learning to enjoy the field is super important. The other thing is you'll notice that there's a lot of code available online, open source projects, that you can just copy and paste to build things, but I think it's super important at the start to code from scratch, because that's when you'll really solidify your understanding. And so I'm a huge proponent of coding from scratch, at least in the early days. And finally, there's a really good resource created by a professor here at U of T named Roger Gross. He created this website called MetaAcademy, which is kind of like an index. It has an index and catalog of great lesson plans and roadmaps for various subgenres and categories of machine learning. So that's a great place to start off if you're trying to develop your own personalized roadmap. So I really encourage you, for those of you who are maybe intimidated about getting into machine learning, I think it's totally doable. And if you have any questions, I'm going to be here floating around later throughout the day. So feel free to reach out to me. I think my email was up at the beginning. Feel free to reach out to me if you have any questions. Yeah, I really encourage you to get interested and get involved with machine learning. Thank you.
Charu, for the great talk and all those great resources. I even get fired up with machine learning as well here now.
And maybe I can make my slides available as well, so if you didn't write things down or take photos, you'll have those resources.
Okay, thank you so much, Charu. Next, let's welcome Vlad, who is a